Welcome to mathandstuff.com. This is A Squared. I'd like to talk to you about, offer to you, a spreadsheet that I've been using for years. The spreadsheet's on the site, but the video is new. Videos are found not on the homepage, but if you scroll down, there's a link for mathandstuff.com on video. We're looking today at this middle one in the three that teach statistics at this point in time, in addition to the web pages which exist. Here's the spreadsheet, which you're welcome to download, keep, use, do whatever you want. Not just for this session, this video, but on a regular basis. I have downloaded my copy and I have stored it under today's name so that I can tell it from other spreadsheets I may have. The purpose is not to teach you the statistics that you can do on other pages. The purpose is to just show you the tool and show you things that you may not have on whatever statistical spreadsheet you have now. Here's the contents of the whole thing. We're just going to start with the mean. I've provided 3 columns. All you do is enter the data, nothing special. You enter the data, the mean, and some changes. Number of pieces of data remains the same. I've just laid it out for 3 samples. You could do whatever you want. And if you don't wish to, use all of the samples, you don't have to. You could create your own. Deviation is a tough topic when taught to the beginning student. Standard deviation is the average spread of data relative to the mean computed in the usual way. I doubt you've heard my definition before. Samples, just to give you an idea, you know the standard deviation. If there's no spread, the standard deviation is 0. If you make it spread out more, the data, let's make that a 12, 17, whatever, should make the spread increase. There we go. Made the mean different, but it also made the spread increase. The table over here with the pink cells is the most valuable for this purpose. I'm pointing out something that may not be obvious. If you change even one score, you know the mean changes, but the difference between the score and the mean changes on every single value, which means their square changes, which means the sum of the squares change, which means the variance and standard deviation changes. I'm going to make this a 1. The mean was 5.4. It's now 5.5, but watch every score as it changes. You're going to look at the pink boxes. I'm going to press enter. Everything changed. Z-scores, just a handy converter, taking a given z-score, compute the z given the x. Here is compute the x given the z. Stanines. I doubt you've seen stanines on somebody else's spreadsheet. It's on mine because I really like looking at what's going on. You know how to compute the mean. You know how to compute the standard deviation. The standard deviation is computed here right through a function, and so is the mean right through a function. but the stanine for a certain piece of data requires you to know the z-score. So here's where you could put students' names, should you choose. Here's where you'd put their data. Let's make this a 90, just for kicks. Let's make this, oh, really low. What's the mean? The mean's 51. Let's make this a 20. So see, we get a score that's now a negative. It's below the mean. But the stanines also changed. Let's see if I can do a sort quick on this. Sort, go from largest to smallest. Okay, now you can see clearly that the higher scores have the higher z-score, and this one of a 90 puts it in the 9th stanine. That's up here. The 0 scores have a standard deviation, have a z-score of negative 1.77, puts it down here. That gives you a stanine of 1. Probability distribution, no big deal. Oh, I should show you. In stanine, that's the function needed to compute the stanine. Not a big deal, just point of interest. Probability distribution, standard normal table. Probabilities, these are the 3 typical kinds of problems: the area below, the area above, the area between. Just input the numbers in input the info in white, and the yellow cell will compute it. If we wanted, oh, let's make this a 2. That means 2 up to 2, where the mean is 0 and the standard deviation is 1.977. That should match exactly with what you know to be true. I haven't listed it here. You know it already. Cumulative tables, you don't need these. This is how we used to do it, but I expanded the table so it had more accuracy and was easier to read. Binomial distribution. This is meant to show how symmetric a binomial distribution is. If this is 0.5 and that's 0.05 and this is 0.95, there are your 2 symmetric values. Here's the 0.815 and there's 0.815, symmetric. This is for n is 4, n is 5. Down here you can change n. Let's make that 10. Make it bigger. Let's make this 0.6. Probability of success is 6. We want to know on 5 trials. And it computes the probability for you. The rest is notes. You don't even need to know them. There's some of how things were computed. That's it. Hope you might use it. If you don't, you don't. If you do, enjoy.